All right, this is the other half of lesson 3.2 and 3.3. Once again, we kind of changed around the way the book organized it, and so we're doing a little bit of 3.2 and a little bit of 3.3, and specifically we're looking at exterior angles of polygons. And there are two goals today. One goal is to understand how to find individual exterior angles of triangles, and then we also have a second goal to understand how to calculate the sum of exterior angles for any polygon. So we're going to start off with triangles, but then we're going to move into any polygon. All right, so let's do triangles first. So once again, we have a triangle, and we're talking about exterior angles. Now, even though we watched a video on this a while back, don't forget to do exterior angles. You don't do something like this. You don't extend the lines and create three different angles on this vertex. What we want to do is we want to pick a direction. So let's say I go clockwise. What I want to do is pretend I'm kind of going around in a clockwise fashion and extending those lines out only in that direction. So I might extend this line out, extend this line out, and then extend this line out. So I'm going boom, 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 and I'm just going in a clockwise manner. I could do it counterclockwise, it'd be the same thing. All right, so then the exterior angles that are formed are this one, and this one. Okay, because of course the other side is 180 degrees because you made a straight line. So we're using these as our three exterior angles. So now our goal today is to figure out what are those measurements. Okay, well, if you think about it, what we discovered earlier was that when you take the angles of any triangle and you line them up, rotate them, and fit them all together, we found out in the last lesson that we got 180 degrees in total. So if I line these two together, and I take that third angle, line it up, rotate it, that we always got 180 degrees. Just like so. All right, so now, let's say, let me change my pen color here. Let's say I'm looking for just this exterior angle. Well, what we figured out in the class was that, well, you know what? Another thing that adds up to 180 degrees is supplementary angles. This angle and this angle. Well, so if you think about it, if the three angles inside the shape add up to 180 degrees, and these two angles add up to 180 degrees, and this angle is the same for both of them, well, then that must mean that this large angle here must add up to the two other angles over here. And so in other words, what we came up with in class was this rule, that the exterior angle measure of a triangle is the sum of two non-adjacent interior angles. All right, now first up, what we mean by non-adjacent means not next to. It means they don't touch. So for example, right here in our visual, here's my triangle. There are three angles here. Let me just mark them. There's this angle, and this angle. Now we're looking for the exterior angle Z. So what we do is we look at the two non-adjacent interior angles. So of the three interior angles, we're only going to use these two because they're not next to our angle Z here. All right, so it always turns out that this exterior angle Z is just X plus Y. All right, so that's a way to find the exterior angle measure using interior measures on triangles. All right, and then we went in a different direction. We started then taking a look at polygons. Now, one thing we need to know is that what we're looking at here is we're looking at the sum of measures of exterior angles of convex polygons. Okay, this rule does not apply to concave polygons. And once again, we saw a video on this, so this is probably already somewhere in your notes. Concave means there's one vertex that's been pushed inwards. It makes a little, like I said in the other video. I think of the word cave because you have this little opening, this little cave that's been pushed into the shape. So this rule that we're talking about only applies to convex polygons. And so it turns out that one way to think about it is like this. If you take a look at this polygon on the screen, you ignore all the pencils. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. See if I counted that right. I think it's 10-sided, so a decagon. And notice how they've already marked the exterior angles. They went counterclockwise, extended the line this way, extended the line this way. And think of yourself putting a pencil over the line and then going around the shape. Well, notice how that pencil makes a single turn all the way around. So if I start here, it turns all the way around the shape. Let me show that to you in this next slide. All right, so to better explain that description, let's model it once again in real life. Here's a pentagon, which I've already drawn in the exterior angles. And so if I take a pencil and I line it up along one of the sides, and then I start moving that pencil so that it lines up with the next side, then the next one, then the next one, and then the next one, and then back again, notice all my pencil's really done is it's gone around 360 degrees. So basically we're saying that if I start with this angle, plus this angle, plus this one, and then back again, that all those angles put together add up to 360 degrees. All right, so that's for our pentagon here. But what about a different shape? This shape has 7 sides, but notice how the explanation is the same. If I say start it up here and I line it up with this top side here, and then I add this angle, plus this one, plus this one, plus this one, and these last two, and I end up back where I started from, that all I've done is I've rotated my pencil 360 degrees. And so that means that all these exterior angles added up equal 360, despite the fact that there's more angles here than up here. It just means that these must be larger angles since there's only 5 of them to add up to 360 degrees, whereas these have more angles but they're smaller, so they still only add up to 360 degrees. So bottom line is, it doesn't matter what the shape is. Any convex polygon, the exterior angles will always equal 360 degrees. Now, another way to think about it, and I've always loved this visual, is if you think about your shapes. Here's a triangle, a pentagon, a hexagon, and look how the exterior angles are marked. If you make this triangle smaller and smaller and smaller until it's infinitesimally small, and basically disappears, notice that the 3 angles add up to 360 degrees. So just like we saw in the last example, that no matter what the shape is, that the exterior angles always add up to 360. Take a look at our pentagon here. Here's a pentagon. Notice how those exterior angles aren't changing. It's just the pentagon's getting smaller, but the angle itself doesn't change. And it adds up to 360. Here's our hexagon, same thing. If you focus on one of the angles, notice how it pushes inwards towards the shape, but the angle itself doesn't change. This line isn't turning anywhere, nor are any of the other lines. They're all just kind of going towards the center and equaling 360. All right, so because of this, it always turns out that the sum of the measures of the exterior angles of any convex polygon, and again, only convex, always adds up to 360. So it doesn't matter if it's got 10 sides, 200 sides, 3 sides, those angles always add up to 360 degrees.